You know the advantages of in-memory computing with SAP HANA. Extremely high transaction processing speeds for you and your customers to make better decisions faster. But how do you prepare for disaster recovery when your database is in volatile memory? In particular, how can you handle full recovery from an off-site location that's hundreds or even thousands of kilometers away? You may have read about theoretical solutions for these challenges. We'll show you a collaborative proof of concept using combined solutions from Deloitte, EMC, VMware, and Cisco that turns possible into reality. In our testing, we were able to log in and restart a report in SAP HANA at a remote site in under 15 minutes. Let's take a look at how we were able to achieve long-distance disaster recovery for in-memory databases in a way that helped lower total cost of ownership while increasing reliability. Our scenario, named Project RUBICON, relied on virtualized SAP HANA running on VMware vSphere. As we'll see later, virtualization was the key enabler to the disaster recovery solution. We also used Deloitte Cloud Service Fabric, which enabled us to work with a rapidly deployable, on-demand private cloud based on the VMware vCloud suite. Cloud Service Fabric freed us from the need to configure and use several disparate resources. Our configuration also relied on Cisco UCS and Cisco Nexus for SAP HANA Tailored Data Center Integration, or TDI, with EMC vMax. This offered us the flexibility of using existing data center capabilities to allow for faster VMware ESX deployment, much simpler infrastructure, and easier management. To test long-distance disaster recovery, we positioned our primary site at the Deloitte Data Center in Suwanee, Georgia, a suburb of Atlanta. And we positioned our backup site over 550 kilometers away at the EMC Data Center in Durham, North Carolina. A secure VPN tunnel was established between the two sites, which enabled EMC Recover Point appliances to handle data replication. Note that we used a standard internet connection for this, which offered significant savings over a dedicated, high-cost, wide-area network, or WAN link. EMC Recover Point provided highly efficient compression for the data, which sped things up substantially. This is imperative when data is being replicated over very long distances. After all, time is money, and your whole business is on hold until you recover from a major disruption. Let's take a look at Project RUBICON in action. At the beginning of our demo, we have a fully functioning SAP HANA Data Mart running in our data center in Suwanee, Georgia. Looking at the SAP HANA Administration Console, we can see a real-time record count. Currently, over 300 million records are imported into SAP HANA, and that number is rising fast. Because we're dealing with an in-memory database residing in volatile memory, it's critical to commit to the transaction log every 1,000 records to ensure minimal loss during disaster recovery failover. Now, let's pull the plug on the SAP HANA environment and see if our data mart survives the disaster. Obviously, disaster recovery is a serious matter. Once a person with proper authority declares a disaster, all the necessary steps for recovery need to happen quickly without any room for error. Using VMware vCenter, we can manually kick off recovery and watch all the recovery steps happen automatically. It really is as simple as pressing an easy button. Using EMC Recover Point, we can see a nice overview of the two data centers and the replication process. Data is flowing from the primary host storage through EMC Recover Point to the remote location in Durham, North Carolina, over 550 kilometers away. And remember, all of this is happening over a standard internet connection. By configuring the network as a simple VPN WAN tunnel and using EMC Recover Point data compression, we were able to minimize WAN costs between the two sites. Keep in mind that you don't even need a dedicated host for recovery purposes. Because we're running SAP HANA in a virtual machine, the designated host can do other work until a disaster recovery event is declared. At that point, you can wake up the virtual machine to make it available for replication. Back in VMware vCenter, we see the failover continuing in an orderly fashion. So far, so good. VMware vCenter automatically kicks off VMware vCenter Site Recovery Manager, which shows the restart of the virtual machines in North Carolina proceeding in an automated and carefully controlled manner. With this process, there's no need to deal with messy and error-prone paper-based runbooks. Now, let's travel 2 states to the north, over 500 kilometers away, and see how things look on the backup host at our recovery site in Durham, North Carolina. Note that this is a virtual journey. We can easily view and handle everything from our primary location because both sites are being managed from a single pane of glass. The whole failover should be complete now, And sure enough, using Secure Shell or SSH on the remote host, we can see that all the SAP HANA processes are up and running. But just seeing processes running isn't the whole story. Using the SAP Business Objects Web Intelligence interface, we can see that our SAP HANA in-memory database is functioning normally, almost as if nothing changed. The database is loading data in real time, as evidenced by the quickly rising row count, which is now significantly higher than the 300 million rows we saw just before the disaster recovery test started. And because our data load process was built to allow for frequent commits to the log, our data loss was kept to a minimum. In our tests, the loss of uncommitted data was less than 5%. The bottom line? In less than 15 minutes, we completely recovered our in-memory database at a long-distance, remote location with minimal lost data. Project Rubicon successfully demonstrated the viability of simple, fast, and affordable disaster recovery for virtualized SAP HANA workloads over long distances. Here are some of the other takeaways from the project. We demonstrated that SAP HANA disaster recovery could be performed with currently available technology. The secret ingredients that made it all possible? Virtualized SAP HANA, tailored data center integration, or TDI, VMware vCenter Site Recovery Manager, and EMC Recover Point. We also demonstrated that this disaster recovery scenario is bidirectional. We could easily replicate the database back to our original site in Georgia. Our disaster recovery configuration was adaptable for multiple scenarios, including an SAP HANA Data Mart use case, an SAP Business Suite on SAP HANA use case, and a complex SAP environment use case. Although we were demonstrating a disaster recovery scenario, the process was essentially just a planned relocation. That shows the viability of this configuration for non-disaster-related remote transfers of SAP HANA databases. Virtualized SAP HANA played a key role in enabling this disaster recovery solution. There are several other benefits to virtualization as well, including the ability to dynamically increase memory allocation on the fly, higher availability, and efficient resource management and automation. And finally, we showed the viability of using a VPN over a standard internet connection, which is a much more cost-effective solution than using a dedicated WAN line. To get the full story on Project Rubicon with detailed descriptions and metrics, visit our Everything SAP at EMC website. Download the white paper from the Project Rubicon resources page at the address shown on your screen.